we're going to change the wording of this question slightly. Instead of using a graphing calculator, take out use and say without. Really changes it quite a bit. You need to know how to graph all of your logs without a calculator. They become your parent graphs, and then we're going to do today all the transformations from our first unit with our logarithms. So the first thing we have to notice is, what do our parent graphs, our basic log graphs, look like? So here we're graphing y equals log base 8 of x. What point? Do you remember what point every single log graph has? 0, 1 is the point that every single exponential graph has. 1, 0 is the point that every log graph has. And then, since this log graph has a base of 8, the second point that we're going to label is 8, 1. Because log 8 of 8 is equal to 1. All exponential graphs have an asymptote. All log graphs have an asymptote. The asymptote on a log graph is at x equals 0. The shape of our log graph, it approaches the asymptote and continues up forever. So this is our basic log graph. And with this basic log graph, we can now say, what are the intercepts? Well, there's only an x-intercept. At 1, there are no y-intercepts. The equation of the asymptote is x equals 0. The domain, all your x values are bigger than 0, but not equal to 0. And your range is everything. So now I'd like you to turn to page 400. I believe that's a blank page. Ooh. Okay, so you are going to try this on your own. Y, you're going to graph. Y equals. So you can do it on the whiteboards first, and then after we'll transfer. If you feel really confident, you can transfer your graph and your work onto page 400. Y equals 4 log base 3 of x plus 1 minus 5. Did you guys off to the side start with your parent graph? Your parent graph has 1, 0, and because the base is 3, it has 3, 1. It has an asymptote at x equals 0. Then if you take those points, 1, 0, 3, 1, and your asymptote at x equals 0, and you look at your transformations from left to right, okay? Again, maybe I go, well, first of all, maybe over here I write, this is the graph of y equals log 3 of x. And some things that are important to note is that the 3 and the x, well, the x is easy to see, but the base of 3 is part of your parent graph. So that means that this base of 3 right here does not affect any transformations. So some of you might have been tempted to think of that as a horizontal compression and say, I want to multiply all my x values by a third because I see a 3 when I move from left to right. So we have to be careful to say, that's part of my parent graph. It's not going to affect any of my transformations. So moving from left to right, if I label these things, that 4 is going to be a vertical stretch. We have no horizontal stretches. There's no number in front of the x plus 1. The next thing we run into is a horizontal translation. That's going to move everything 1 to the left. And finally, we have a vertical translation, 5 down. So when you're moving from left to right, okay, that means that vertical stretch, we're going to the first set of arrows that we've always done all of our stretches and compressions. The only one is you're multiplying your y by 4. So this point is still at 1, 0, but this point is now at 3, 4. And after that, we can do our translations, 1 to the left and 5 down. And you get the point 0, 0 and 2, -1. The other thing is the only thing that's going to affect your vertical asymptote is if things get moved left and right. And we do move things 1 to the left, so our vertical asymptote is now going to be at x equals -1. Yes, it should be 0, -5. Thank you. Yeah, I just moved it 1 left, but forgot to move it 5 down. And so now that we've got our points, that we would have realized that mistake when we went to graph it. X equals -1 is our asymptote. We've got the points 2, -1 and 0, -5. When we go to sketch this, there's our final graph. Does it look like it's been stretched vertically, moved 1 to the left and 5 down? It appears to be. So that's your first one. Here's your second one to graph on your... Yeah? Yeah, you can come grab another pen. If the pen is super dead, just throw it right away. There's erasers in there too, but they are out. So you have to borrow an eraser from someone else. So here's our next one. I'm going to get you to graph y equals 2 natural log 1/2 x plus 2 minus 3. So this one, a little bit more difficult because you're dealing with the natural log. But when you think about the natural log, it's really the same thing as every other log. It has the same shape. It goes through 1, 0, just like every other log. And what's the base of the natural log? The base is e, so it goes through e, 1. It also has the asymptote at x equals 0. So that part's the same as all the other ones. This one was also a little bit more difficult because you had to remember to factor out, because there was a horizontal stretch and a horizontal translation. So we have to factor out that half. Now, when factoring out a fraction, this is the number here that often causes people difficulty, that 4 that I wrote in there. So how do you figure out that 4? Well, it's easy to take the half out of the x because you know it's just going to be the half and the x is going to be left. But if you think about it, if you're checking, you'd have to distribute, right? And a half times x is equal to half x. And you'd have to say a half times what is equal to 2. And I find that that's the easiest way to figure out that this is going to be a 4. Because a half times 4 is equal to 2. And then we still have the minus 3 afterwards. So now that we have that, we can say, well, I'm going to take my points, 1, 0, e, 1, and my asymptote at x equals 0. I'm going to do all of my stretches and compressions first. So the 2 outside, that means you're going to multiply y by 2. The 1/2 inside says you're going to multiply your x by 2. And so you're going to get 2, 0 and 2e comma 2. Doing our translations next, we're going to go 4 left and 3 down. So 4 to the left and 3 down, that point will end up at negative 2, negative 3. And 4 to the left, you would just write it as 2e minus 4 and 3 down minus 1. The only thing that's going to change your asymptote is if things are shifted left and right. And since we are going 4 to the left, our asymptote is going to be at x equals negative 4. So at this point, we can now sketch our graph. 1, 2, 3, 4 to the left. Start with our asymptote at x equals negative 4. Label our points. So negative 2, negative 2, negative 3 is the easy one to label. 2e minus 4, comma, negative 1. Well, e is 2.7. So if you were doubling 2.7, you would get 5.4, and 5.4 minus 4 is approximately 1.4. So I'm going to just estimate where 1.4 is and label 1.4 negative 1. I'll still label it exactly, 2e minus 4 comma negative 1. And now when we sketch our graph, this is what it would look like. You don't need to find the y-intercept. Once you've got 2 points labeled on your graph and your asymptote, that's enough for your sketch of a log graph. Okay.